Ask an AI the same question twice. You can get two different answers, word for word. That is not a glitch, and it is not the model being moody. It is the entire mechanism. And by the end of this video, you will know exactly why. Picture DraftPal, a small writing assistant, finishing one sentence. The cat sat on the blank. We are going to build, from scratch, on that one example, exactly what happens between you hitting enter and a word appearing on the screen. Tokens, scores, sampling, the whole loop.
Here is the first thing to unlearn. A language model never sees a finished sentence, and it never writes one in one go. It only ever answers one tiny question, over and over. Given everything written so far, what is the very next chunk of text? Answer that question once, glue the answer onto what you already had, and ask the exact same question again. That loop, repeated, is the entire engine. Nothing more mysterious is happening underneath.
Step 1. Your sentence becomes numbers. DraftPal takes the text, "the cat sat on the," and hands it to a tokenizer. The first line is just that string. The second line calls in code, and the result, 5 numbers, is what actually gets used from here on. Notice it is 5 tokens, not 5 words and not 5 letters. Common words are often exactly 1 token. Rarer or made-up words get chopped into several pieces instead. The model never reads English. All it ever sees from this point on is this list of numbers.
Here is the picture most people carry around in their head. The model somehow knows the sentence is finishing with the word Matt, and it just says it. Reasonable guess. It is also not what happens. What actually happens is closer to a graded guess, scored across every single word piece the model has ever seen. Not one lookup, one enormous scored list. For every one of those tokens in its vocabulary, tens of thousands of them, the model produces one score. Turn those scores into a chart, and for our sentence, it looks something like this. Mat, 41%. Chair, 19%. Floor, 12%. Then thousands more candidates trailing off towards 0. That chart, not a single answer, is what the model actually hands back at every step. Here is that step in code, line by line. First, the model produces logits, raw, unscaled scores, 1 for every entry in the vocabulary. Next, a function called softmax turns those raw scores into percentages that add up to 100. That's the very chart you just saw. Then, instead of grabbing the single highest one, the code calls sample, a weighted roll of the dice across that entire chart. Whatever wins gets appended onto the token list on the last line, and we move on. This is the part almost everyone misses. It samples. It does not always grab the top score. 41% wins most of the time. That is what 41% means. But sometimes chair wins instead. Same model, same prompt. A different roll of the dice, and you get a different word. That is not a bug in the system. 2 different runs of one prompt disagreeing is exactly what this mechanism is supposed to do. And that chart is never fixed. It gets rebuilt from scratch at every single step, out of whatever context it is given. Add 4 words up front. Write this like a horror story, and ask the exact same question again. Matt collapses to under 1%. Coffin jumps to 99. Same sentence, same blank to fill in. A different chart because you handed the model different context. Put all of that together, and this is the whole engine. 5 lines that matter. First line, turn the prompt into tokens. Then the loop. Score every candidate, turn those scores into a chart, divide by something called temperature first, sample 1 token, and glue it onto the list, never to be revisited. Check if it's the end of reply token, and if not, go around again, from scratch, with 1 more token of context every single time. Temperature is just the randomness style. Turn it towards 0, and the top score wins almost every time. Turn it up, and the long tail gets a real chance to win instead. And here is the cost, in plain numbers. A short DraftPal reply, 40 tokens long, is not one question asked once. It is that same tiny question asked 40 separate times in order, 1 full pass through the entire model per token. There is no shortcut where the model sees the whole sentence in advance and writes it in one go. Every single token you get back was its own full computation. Now, the failure mode this creates. Once a token is glued onto the list, it is never revisited. If the model glues on a wrong guess, a fact that does not exist, a name that is slightly off, it does not go back and fix it. It keeps asking the same question from a context that now includes its own mistake and confidently builds the next guess on top of it. That is the seed of a hallucination.
This same mechanism explains something people call personalization. The model does not remember you between conversations, and it has not learned who you are. Your last few messages simply get typed back into the context alongside the new question. Same tokens in, same scores out, same softmax, same sample step. It is not a smarter model. It is a longer prompt, reshaping the same chart you just watched.
So here is the whole thing, start to finish. Text becomes tokens. The model scores every token in its vocabulary and turns those scores into a probability chart. It samples from that chart instead of always taking the top slot. The winner gets glued onto the tokens, and the entire question runs again. Context, genre cues, your last messages, anything at all, reshapes that chart every single time. And once a token is glued on, there is no going back.
If that made next token prediction click, hit like and subscribe. One concept, all the way down to the code, every single time. There is a 90-second version of this in the description if you just want the short version. Next up, what actually happens inside that model function to turn tokens into those scores in the first place?